So right here is our asbestos containment. So all the debris is getting removed from the building down an elevator shaft, and then it moves into the triple chamber that's all sucked in from negative air, right? And to make sure that we don't have things that are getting outside airborne that us and the public would breathe. And then it goes into those dumpsters right there in our north block. It's getting awful. Doing about 7-8 dumpsters a day, ish. Who's actually stay on the sidewalk?
Who does your dumpsters for us?
They have, I think, C&H.
Okay.
This is just a smaller outfit. Yeah.
That's probably the only people that would service it like that,
Yeah.
Seems like good dumpsters.
Yeah. They only have, I think, a small little company that eBay uses. They only have like
All they do is they just go to the dump and just dump it just like you and I.
Right.
Yeah. Nothing too fancy about it.
So one thing, before we could start the demo, we had to do some relocation of where staff were working inside the building. One of them, there was a couple MRI units or rooms. So we actually had to expand and put temporary MRIs outside. So we did this kind of as like a make-ready work is what you call it. You make ready is you make the project ready to actually do the real project. So MRI trailers, little pad here. Skylar was part of that before I got here. I don't know if there's anything unique you want to mention about it.
Yeah, so this was a emergency department entrance. There's a whole pavilion of like a what do you call that? A big covering over the
Canopy?
Yeah, canopy. Giant canopy over the covering here. So we had to demo that. And then UC Davis as-builts are very poor. So to put this pad on here with the weight that it's going to sustain, it was a giant challenge just because there's all kinds of utilities underneath that are not documented. So it's impossible to tell which ones are live and which ones are not until you start investigating them. So we had a lot of live utilities, we had a lot of dead utilities. We had to protect them all in place just with the pad on it. So basically I had to cover them in slurry, foam padding, and then compact on top of that prior to ever getting the concrete finished on top. So
What's the value of one of these trailers?
That trailer's about $1 million.
$1 million for an MRI trailer.
With an MRI? Yeah.
Pretty heavy duty equipment right there, right?
And then, do you know what the value was just for the make-ready work to get all the pad and utilities?
No, I don't.
Okay.
I don't.
Probably hundreds of thousands of dollars, though.
It was probably a little over $100,000.
Yeah.
Just for this.
I think with the red projects and this, it was like 5 to 6 million.
Yeah.
5 to 6 million.
Yeah.
6 million. That's what it started at.
Uh-huh.
And then anytime you start digging or you start opening the walls, it changes, right? Just running
But that includes like other patient spaces that we had to build out.
And was this part of the design build?
Yeah. Yeah. It was a
proposal?
design build with a different designer.
Okay.
And then we had LPA for the actual main project.
Do you guys want to kind of explain what the design build process was for?
Let's continue walking down because
yeah.
they're waiting for us over there. But yeah, we'll get through that. This way. So you can actually see the old 2-story building, which is the brick facade. So that right there, that kind of sticks out. We call that the north finger. That is 1920 construction right there. And then the tower behind that, the 8-story tower, that's called the East Wing. That's active patient care, where people were staying overnight, getting treatment, and our building is connected to it. That we had to sever all the utilities crossing between each floor, and then put 2-hour fire-rated barriers in between. So that's kind of our project. So that's active. This is a project that I think it was built about 7-8 years ago by Turner Construction. It's like a north addition, mostly I think nurse and doctor offices, admin offices. They have conference rooms in here and whatnot. You guys are getting the back of house tour. We'll go by their loading dock too. that to like So this building right here, there was actually a building between the east wing that I just mentioned and this building, which is the Davis Tower. There was the east wing was built in the 60s, so they expanded upon in the 60s. Then there's the University Tower that was built after UC Davis took it over, and that was built in the 80s. The Davis Tower right here, I think it's 12 or 13 stories. That was built in the early 2000s. I think Swinnerton actually built that. Adam's previous company. Still rocking the hard hat.
Got my Swinnerton on today.
Yeah, right?
It's only a helmet style hard hat.
Yeah.
You might have an SPP.
Yeah, I think I got one to sit in my
I'd rather
garage.
walk the Swinnerton though.
Yeah, I interned there.
Oh, maybe that's why.
Could be. A few years ago, I did a BBC.
Oh, yeah? What project do you work on?
John Muir,
Okay.
the OSD.
Is that Colorado?
Oh, I don't even know.
I guess you're just doing BDC.
Oh yeah, I was working on that, and then I was did some small stuff like for these. I was there 3 months. It's cool to design some utilities and raceways. All they gave me was a point cloud, and they're like, here, go ahead and build some of these systems.
Some big buildings there.
Water tank over here?
It's like one of the original water tanks. That was actually
I
there.
don't even know where all this money comes from. I don't even know where all this money comes from.
So are you guys bringing the buildings down?
Gotta get every angle.
Now they're talking about upgrades to the East Wing to make it last.
Should have started off like a vlog.
They don't know. And it would
Hey
be,
everyone,
like,
welcome back.
07 through 4 would be compared to the those fingers, they're intertwined with the East Wing.
Hey, go ahead, right, hit him up.
You start taking that building down, you gotta take the whole elevator.
The food truck.
It's going to eliminate an egress. They had a project to put in a stair, they could power train the stair and keep it in the middle of the building like
What's
held up our project. However, if you want to demo that, you're not going to have any fire egress because it's going to eliminate that new stairway.
Yeah, this is new. I'm like,
Well, you know,
it's like you just get it done, you know? Like,
farm life is going to play and everything, right? There's all these different governing bodies that manage different aspects of it. So you got to get the committee on board, pass all your permits, plan it all out, farm
5, 6, 7, 8, 10, 11, 12. See about 26 one.
That's about right.
Yeah.
CM10 or what?
It's CM20.
20.
Yeah.
Okay.
Remember Adam?
No.
No. Okay.
Cameron.
Cameron? Yeah.
What year did you graduate?
12.
It was 12. Yeah. Okay. Nice. Yeah. So he was in the CM program too. We overlapped a couple years. How you doing?
Awesome. Let's do a quick PPE check. See gloves real quick, throw them up. All right, I don't see any naked heads, so we're good. Boot check, looks good. You guys talking about the project some?
Not really. No.
Two projects.
Yeah, I didn't know what, I mean, Carp caught me off guard. I was like, hey.
Yeah, no, we went over a little bit about our project, and then as we walked over here, we went, showed them, hey, our building was built in the 20s, expanded in the 50s, and then we kind of just showed them each building as it expanding, and then obviously this is the today new construction, right?
Got it. What level of detail? What are we looking to get out of today?
Just general knowledge of, steel erection, crane jumps, concrete, just what you have going on.
Okay. Just walk out there, we'll talk to them.
Yeah, sounds good.
We're obviously here to scan everyone in.
Yep.
Everyone signing the unicorns?
Yeah. They had them already.
So when we walk on site, just make sure we all stay close, don't walk.
Don't wander off.
Yeah.
Get lost.
Start working on a project.
Don't pick up a hammer. We'll pay you.
So when I go work with my dad, does he have a food truck as well? And well, all I gotta say is, sir, thank you for your food.
Privilege?
What's the purpose of this?
Students? What do you mean?
Oh, I see you got a badge in.
Yeah.
I didn't see you doing that over there.
You're like, what? Yeah, it is. I'm like, fuck. I hope it doesn't boot me out. Quantity, security. How you doing?
My bad.
Hey, start waving high. See if they say what's up.
Marines Bay Fire Protection. Kind of cool setup. Yeah. What's that?
So you don't spray all of that.
Floor deck is the roof, and then you got a little elevator penthouse that's 15 and 16.
Those are some impressive beams, dude. Those are
Oh yeah. Have you shared the stats?
I have not.
All right, everyone, huddle in so we can all hear it. It's real loud.
So I'm not a steel trade manager, but I'm going to just rattle off some of the facts. The building's 16 floors with 2 helipads. It's about just shy of 1 million square feet. It's going to have 332 patient beds. All the steel here is plus or minus 15,000 tons. The largest beams, I'm told you guys are out here kind of looking at structural, is a 14 by 730. So if you don't know what that means, it means each linear foot is 730 pounds. Let's see, we got 30 sequences. So the way that this is built is essentially kind of like thirds. The podium's got quadrants, but like sequence 1 right here was about to D line, A, B, C, D, and it was 3 stories up. So you imagine that is one sequence, and we got 30 of those sections. It's going south to west, south to west, south to west, and eventually we got the south tower crane. It's going to take off in kind of a parallel fashion. Schuff Steel is the fabricator and erector of the structural steel, and all the steel was built in California and Arizona. Schuff, S-C-H-U-F-F, Schuff. We won't be looking at it, but in the pit here is a mat foundation, and it ranges from 4 to 8 feet thick of concrete.
Are you guys on piles or anything?
No.
No, really. Just real. How big are the footings? A typical column.
Again, so it's a mat footing, 4 to 8 feet.
It's all poured monolithically with the slab.
Well, so above the mat foundation, we've got another 5 to 3 feet of permeable gravel that goes in with all the plumbing and electrical, and then there's an architectural slab that's 5 inches above that.
So we learned a little bit about foundations in class, and so even like a slab on grade thickness is still several feet. So it's a mat foundation, meaning the foundation is tied in the slab on grade and everything else. So all the concrete at the bottom of this building ranges from 3 feet to 8 feet.
So the actual foundation, again, you say 5 feet. The foundation is just the whole chunk, 5 feet of concrete.
Except for the floor end over there where it's going to cantilever out, the foundation is 8 feet. So it's 8 feet of rebar concrete.
And then how are you guys one level underground? One level underground. Do you guys have any shoring systems or anything still in place? We were learning about that.
All the perimeter shoring is scheduled to remain.
Oh, good. Landed, shotcrete or something?
We take it down just to where the waterproofing membrane will go.
Okay. What's the contract value?
$2.5 billion.
$2.5 billion? All right, so we talked about billion-dollar projects. This is $2.5 million. So 1 million square feet is $2,500 for every square foot of the building. That's very expensive, but it's a hospital. It's probably the most expensive construction and the most difficult construction in the world.
We're MEP, but we're MEP.
MEP? All right. Well, you guys want to talk about any MEPs? I mean, is there a cup or what do you guys?
You guys about MEP all day.
Real quick before we get into that, do you know when you might be jumping the tower crane?
This weekend, I think.
This weekend? Okay.
Yeah.
So usually when, I don't know if you guys know,
You can talk and I can chime in.
Yeah. So usually, like when we jump tower cranes, when the building is taller than when the crane is freestanding, you need to be able to have an engineer design to tie it into the steel structure once it gets to a certain height, and then it self-erects itself by a self-climbing kind of a hydraulic jack that goes around all the main post that holds up the cab and the jib and the counterweights, right? So once you get that in place and you're able to tie the structure, it sounds like in the next week or two, they're planning to actually raise these cranes up so that they can keep on erecting the building. You said the building's 15 stories, and right now you're erecting at what level? 9. They're at level 9, so they're a little more than halfway up right now. You know if it's one crane jump or two?
One crane
One crane jump.
This will be this weekend, and 2 weeks will be the south crane.
Yeah. So if you're not doing anything this weekend or next weekend, watch from the street outside. It's actually a pretty cool process. Or you can YouTube just hydraulic crane
So
jumping.
it's self-erecting. You don't need another crane to jump in.
It's going to jump itself.
Nice.
Yeah, it's going to use its own crane itself to do it.
So basically what it does, it lifts itself up so you get a section in. Right? So you got iron workers. So we talked about tower cranes a little bit. Well, you guys can see it going up through the middle of the building there. Why do they put it in the middle of the building? Because they have to be able to reach everything. So that when you finish the building, you've got a big hole in the building, you're going to pull the tower crane, or you're going to disassemble the tower crane out of the building, and you got to infill that hole.
So this tower crane is in an elevator shaft. We've got a man hoist that's similar to what you're explaining, going through the building. We'll infill that. Man lift on the south side's on the exterior, so we'll just have some patching more or less. And then the south tower crane is in all the areas you wouldn't want it to be.
So what we're trying to get you guys to think about is like this stuff isn't like set in stone, like it's an industry standard thing. These are things as a general contractor, if you guys go work for Clark or McCarthy or these big companies, there's real life people that are figuring this out for every project. And every project's unique. And so, I'm trying to get you guys to understand, as potential general contractors, when you work for these big companies, it's going to be your responsibility to figure all this stuff out. It doesn't figure itself out. There's gentlemen just like this and women that are figuring out all these type of things, how you're going to piece together the erection sequence and everything else. So that's really impressive. $2.5 billion.
And like you mentioned, the south tower crane is in the middle of our electrical room on level 4.
Woo!
Nice.
The main electrical
That's
room.
not the ideal pot. Who decided that?
You guys are MEP managers?
We weren't here at the time. So
We talked to that superintendent.
I'd be the estimator.
hurry up!
You're going to save a ton of money going up through the elevator shaft.
It's the south crane coming down first.
It is. And that's this shorter building. But we got like 6 weeks for that thing to come out, and we need to have power going.
And these are cool cranes or luffers, that's what you call them. So in addition to just the boom rotating, the boom goes up and down. Right? Or jib, boom, what do you call it?
Jib, either one. Well, the one reason why we were kind of laughing about the electrical room thing, right? When you're building, you have priority rooms, right? Obviously, to make the building go alive in the MVP world, you need your main electrical room and all the floor-by-floor electrical rooms done first. So we call those priority rooms. So you want to have those built with our framer, our drywaller, get them painted so the electrician can start putting up panels, putting in conduit, pulling the wire, and get those terminated as quick as possible so that you can start using permanent power instead of the temporary power. And then that starts distributing. So putting a tower crane in one of those main electrical rooms, definitely not the best idea. I'm sure there's a method to the madness of why they had to do it here, and there's a plan for it, so that there's plan contingencies for everything that you do. But just make sure that anywhere where you put something has a cause and effect of what it could impact. So those are all the things that you want to evaluate when you're locating all the temporary construction, like cranes, man lifts, welding machines, temp scaffold stairs, all that. So
Yeah, this is. Oh, go ahead.
I just have a question. You're using a tower crane. Do you not have to do a horn like you do?
I was actually just wondering where their horn was too. I wasn't going to say it, but I'm glad you brought that up.
They pretty much own this area though. So anytime we do lift anything overhead, like if we're gonna lift something down in the hole, we always use a horn. But these guys right here, they own this spot right here, and they're lifting over their own guys. And so
The program is don't be under the steel.
No.
They're
You
doing
can
their
see all
thing.
the steels cordoned off. Everyone that's in here is an iron worker.
They're immune to steel.
Steel doesn't hurt them. That doesn't hurt them.
So, I think kind of the last topic on the structure, you guys toured an older building. You probably saw some moment frames, some of the bracing. You won't see that out here. This is side plate construction, so you see like this column here, supporting level 2. It's got big side plates, all bolted connections. All the moment is in the foundation and through the beam. So you've got bigger columns, but the trade-off is the time and not having to weld all your connections and not having the space of the moment bracing through the building. So you see all vertical and horizontal beams only. You will see some temporary braces. Those will be cut out.
How many workers do you have like a typical day?
The steel crew is at 88. The plumbers, the MEPs, you know,
20 each on those right now. We have mechanical wet, they got 10. We got mechanical dry, there's only a few of them here. Plumbers 20, electricians about 20. We have about 100, maybe close to 200 people on site right now.
We're projecting to be in the 1,000 to 1,500.
Wow, 1,000
things are going.
People working on site?
Yes.
Right when they're hanging drywall and stuff, you got every trade on site. So if you guys heard that, at the peak, 1,000 to 1,500 workers on site. That's a lot of people.
That'll probably be in about a year.
Yeah. Oh yeah. That's gonna be
Insane.
Summer.
Is this a design build project?
Yeah.
Design build. What is this? It's a hospital tower? Everything?
It's got everything.
Everything?
It's got it all. We got 20 elevators.
It's 40 buildings.
Go ahead.
Who's the architectural and engineering?
So Smith Group is the architect. Degenkolb is structural. Mazzetti is doing plumbing and mechanical. Silverman and Light is doing electrical. These are the main ones.
Everyone's under you guys? All the
Yeah.
architects and engineers?
All but TCOM's under the kind of one of those.
So you guys can look around, you know, big thing on your lab reports is, you know, temp construction, safety. What do you guys see for safety?
If we want, we can spread out. We're gonna walk down this east side and then bring it down the south side.
Okay, yeah, let's go. Not that much.
So this guy was the radio, or on the far side, this one that
That guy with the radio straight ahead, he talks to the crane and communicates to them.
Only one person talks to
Yeah, especially those dude, that's the job you gotta get. For like a lot of responsibility.
That would be wild.
That's like the one you don't want to be behind. Final
So you stop right here. You realize you're going on a school fucking field trip. Chill out. Yep. Need this right here. Right here. More. You want us backed up a little bit? There. Nobody talk. The lift moving. Go ahead. Go ahead. Go ahead. You gotta be able to speak English. Come on. So along with the steel structure, you need to have fire protection. The standpipe here needs to be two floors below where the steel is erected. We have lifted some fire protection pipe here. All part of the program. Go to the goats. The goats are nice down on the left. And there's some pigs too. They're real cute. You guys barbecuing? Oh man, that's the other guys.
Yeah. The fire sprinkler was put under 1050C.
Yep.
Yeah.
So yeah, the standpipe needs to stay 2 floors below.
Right. Is it under there, the one is that all temp steel and shoring?
Yep.
So if you guys notice over there where you have the man lift and those catch nets are hung over, is that level 3 or level 4? Level 4. The level 4 is where the building actually starts. And the columns, the 4 of them, that's actually temporary steel for just going in the building where they start on level 4 and up. So they probably weld that steel in place and pour it in the slab. Those temporary columns going to the ground, you see, need to stay in place so they can get removed. Obviously, you guys have 2 tower cranes, right? So that allows for 2 different ironworker crews to happen at the same time. So we're erecting steel on both sides of the building, and make it all go up at once. It's a pretty big project, man. Yeah. Huge billion. I joke with everybody though. Simple roof.
See with Halifax.
Yeah. Well, you guys have any other questions? What's going on? MEP, structure, concrete? I'll talk just structure kind of sequence a little bit. So how is the standard for tie off? Anytime you're working over 6 feet, you have to tie off in California. Washington, that's important. But California, kind of 6 feet. 6 feet seems kind of
Tie off every
so
6 feet.
Tie off, right? You actually see some extra safety measures in place. So there's catch nets over here that cantilever the building. That's for not necessarily fall protection if someone falls off. Obviously, it would catch someone if they did. If their yo-yo and harness didn't catch them beforehand. But it's mostly for people walking underneath. If like a bolt or a nut or something fell off the building, it would catch that before it lands on something down below, right? Yeah, you see them all wearing their harnesses. You know, they're tied off. Guardrails they have, right? So the most standard is you have to have cables or guardrails. The top rail has to be 42 inches or 5 inches. The rail is about 42 inches. And you have to have a toe board as well, or anything over 6 feet high, or you'll be tied off. Typical steel erection sequence, right? You usually do about 2 floors at the same time. So you'll erect 2 floors, and you go up to the next 2 floors, metal decker comes in, welds all the deck down, with all the studs. That's usually on like the 3rd and 4th level below steel erection. And then usually between levels, the 6th floor to 8th floor, steel, like below where the steel's getting erected, you'll start putting all the MEP parts, so the sleeves or cans that pipes will future go into, or inserts to be able to anchor hangers overhead. Those all get installed. Then your rebar guy will put the rebar down, and then you pour the concrete. So between where you're erecting steel to pouring concrete, you usually want to maintain about 8 floors. So that's, unless you get an approved engineering analysis that lets you go higher than that, you need to pour your concrete deck at least 8 floors below where you're erecting your highest floor. That makes sense. Just because the higher you go up with steel, it's not fully, locked in place, the more it can do this unless it's extra engineered. So Salesforce horsepower, engineered to go 12 floors of steel before we pour the concrete. And that would just be able to maximize our schedule. We were doing a floor every 3 days. I don't know. What's the?
After we're doing a floor, it's hard to measure because we're doing it in tiers. To put things in perspective, we started slinging iron in June and then September, and we're 8 years up. 3 months.
Started iron in June.
Top out last 6
Steel in December, 8 floors up.
January-ish or so 14 floors in about 9 months.
To reiterate,
14 floors in 9
we
months.
got our first slab on metal deck 4 on Tuesday last week. This right here will be poured in the next week. We're doing inserts right now. And to reiterate the fourth dimension, our level 1 deck, you can't see any steel in the pit. That's all cast in place. So it'll be formed up with wood. And that's really where the engineers are concerned about locking the structure in. So then they've set it up to 9. You guys need to have the level 1 board. So getting level 1 board is pushing the path. Yep. That's what we're jamming down. Yep.
You guys all know what's behind you? The green thing.
Yeah, come on through.
Going off site, all the banging and stuff, so that it minimizes disturbance for neighborhoods and the public outside, patient spaces.
This is a noise control system.
Sound out a lot better than this. All right, good. I think so. We could go that way if you want to, or we can go all the way back, whatever's better for you.
process landscaping protocol. I think almost like rental subsidiary for doing. They also do those trailers. Oh yeah.
Sorry, so this is a noise control system so that the noise of all these banging and the construction doesn't go towards the residents, and it isn't that much of a hassle or bother for them. Temporary facility, you could put this AED eye watch system. Got fire extinguisher right here too. $2.5 billion project. Scuff, I believe, is the metal supplier. SCHUFF. Yeah, I do, bro. I'm getting asked out right now. No, I'm just kidding. No, I just on the camera, bro. I'm getting rizzy, bro. There you go.
I'm looking trying to like make one connection first.
That's good, bro.
I'm trying to get an internship at least by this summer. Like, I need to stop looking lagging over.
Yeah, no, I wasn't able to. I think I couldn't this summer because I had school. But yeah, we need to get an internship this summer for sure, bro.
Oh yeah? Nice. Yeah, very cool. Yeah. Okay. There you go.
Yeah, I'm only in it because like my dad, he's
All the excavation.
I know. Yeah, exactly. It's probably settled down 7 feet over the course of 100 years. Right. I can't believe how big those steel beams are. Pretty big. They're pretty big. That could, yeah.
Are you doing Reno this year or no?
I'm not sure. Is it too late to sign up?
I think we'll still find out Saturday. I can't do it, but I'm in. I don't work out. But they have one Friday.
Or no, I'm looking.
Next year, for sure.
I don't know. I'm still thinking. I might do it. Yeah.
Yeah, we did a never posted tailgate.
But I'm still thinking though. I'll ask the professor if anything. See what he says. Nah, not when I'm recording. I got a gatekeeper. No, I'm just kidding. Yeah, Look at the professor, guys. So inspirational. Just the way he walks makes me smile.
Yeah, right? That's funny. Well,
Nice, we got some shade. This strap isn't helping. It's trapping all the heat. Oil tank. I applied for the state, but I'm just seeing if I'm gonna get called back. Yeah, I'm waiting though. 'Cause it's just a student position, but if not, I think I'll just apply to those other internship offers that I got. Well, not offers, but
When you're applying, what do you search up? You search up SEM, like.
sorry. Mostly I get notifications. Like I get, it's because I went to ARC and I get notifications from any internship opportunities. And I just go there. Like the one I saw was pretty good. It was like April through July. And it was, yeah, it was paid. And everyone says that it's a good company, but I'm just trying to look too. I'm gonna apply obviously to a few. I'm not just gonna apply to one.
Yeah, 100%. I'm really trying to wait for that to get something like, for
Yeah, I saw Chevron also offered.
Chevron, okay.
Yeah, I was like, what?
so we're gonna walk in here. We're gonna walk up to level 1 first. You're gonna be able to just peek one by one or maybe 2 people at a time looking at the window for a few seconds just to kind of see what's going on with the bulldozers or bobcats, little skid steers knocking stuff over. And then we'll continue walking up the stairs up to level 3 so you'll see what it looks like once all the demo is complete. It's just the open shell, right?
Hey, Forrest, I'm gonna go check on these guys.
Yeah.
Sounds good.
Or I'll take the back then. What's the contract value of this?
So our contract value is about 49 million
49 million for demo.
for all the demo. What's that?
Crazy. 2.5 million.
Well, with the red projects and change orders, probably 56, 57 million. Yeah.
50, 60, 70.
Yeah.
Hard numbers.
So don't see much going on. There's actually one guy in there. He's all suited up. They have to have full respirators on because it's an asbestos containment. There's negative air fans that are sucking air in so that air is not coming out. It's all being sucked in. That's why you see this pretty tight, getting pulled inwards. And then of course, one big safety aspect is the asbestos sign danger. Make sure you don't go in unless you're trained and suited up. If you guys want to, you can peek at the level 2 window as well. They're just about done with demo, but they're still cleaning it up a little bit.
going up to 3?
I don't know.
Oh.
Did he say we're going up to 3 or not? I'll go up there now. Yeah. Okay, just went into level 3.
Wait at level 3.
It's a nice door on it. It looks out of place.
Almost everybody. You guys have any questions on what you saw on through those windows? Some of you probably heard, but you probably saw a couple people with full respirators in those windows, right? Mostly all full bodysuit as well. So they need to be certified. There's like a week-long training that people that are doing asbestos work need to go through and get certified before they can be in those containments. Obviously, full, N95 plus respirator is required, just because you don't want to breathe in the asbestos and lead that can cause harm in your lungs and your body. So they're fully trained on there, and that's what the acre containments are. Just like this one right behind you guys, we put up the asbestos sign as a safety feature, also to make sure that people just aren't aware they shouldn't be here. Like they know, like, hey, if you go in here, it could cause cancer, right? You'll see that plastic is sucked in quite a bit, and that's because of all the big negative air machines that we have inside the containments to make sure all the air is sucked in, creating that negative pressure and not being pushed out to where we're not protected. So that's why you see the plastic kind of pulled in a little bit. That's called negative pressure, and we have different tools called a manometer that'll read what that negative pressure is. So take a look around, right? What you see is a building. This brick right here, this was the exterior of the 1920s building. They went up to, the roof was at level 3, which is what we're at right now, right? And when they expanded upon and built this steel building on top of it, they left some of that exterior in place and just chiseled away some of the exterior features and brick that were part of that building, which is pretty crazy, right? So you still see these, this is our structural walls for the original building, but when they did the expansion, they added steel and support so that they're not as structurally needed for the full building. Obviously, you see steel columns and steel beams. A little bit different than what you saw over at the California Tower. They had side plate connections. This is a little bit different, but somewhat similar. A lot of rivets were used back in the day, but also they still had the same kind of nuts and bolts as well. One of the biggest differences, though, are these trusses that span from the main beams to beam, right? Most steel erection nowadays, like what we just saw at California Tower, there'd be individual beams probably spaced every 7 to 10 feet that more closely look like the orange beam here instead of these trusses. And then there's the mesh fabric that spans, and that was just put down to hold the concrete when they placed the deck and left in place. So instead of metal deck, which you see over there on new steel structures, the metal deck is laid down, welded to the steel, and then the rebar is put on top of that, where you just pour, and it's formwork, right? Here, you can actually see the depression, and when the concrete was poured, it actually made the bellies in that fabric. Definitely unique. You do not see this nowadays. It's funny walking with the structural engineers. We were opening this up like, what were they thinking back then, right? But obviously the building's still standing, so it works, right? We just typically don't see it nowadays, but definitely interesting to see, you know, the old windows, the old exterior of the building. We'll walk this way and I'll show you where the building used to connect to the east wing. So right here, these used to be old windows, and there used to be just a third wall in front of those before we demoed out the walls. On that side was the elevator lobby, the main elevator lobby for these elevators right here, the North-South Tower, and you used to be able to just walk right through to the elevator lobby of the East Wing. Before we were able to demo this whole walls and ceilings, we had over 1,300 MEP crossings, electrical conduits, ductwork, plumbing, hydronic lines. They cross right here or over there between 7 floors that we needed to cut. First, de-energize, make sure it's safe to do so. Do any refeeds if there was power that was feeding from the North-South Tower, feeding to that tower. We needed to do some make-ready refeeds to make sure the East Wing is self-sufficient on its own first. And then we were allowed to cut all the utilities that cross between the buildings. Once that happened, then we built 2-hour rated walls. So this right here, these are all 2-hour rated walls, meaning that theoretically it would take 2 hours for a fire to burn through the wall to get to the other side. And so that's how we're kind of seismically and fire saved from the East Wing, the occupation space, from this, you know, building that HCI calls not safe to be occupied, right? Are there any questions with that?
Is that building just right up against the wall, or is it a walkway?
There's about a 4 or 5 inch gap between this building and that building. Yeah. So there was, you know, when walking across, sometimes you'll see expansion joints, like a little plate. You don't even really notice it in the building, but you can walk right over that on the floor. Yeah, but it's pretty close by. Yeah, definitely. So we had to do that on all floors, yeah.
Those like some on the side, like some
yeah, we'll go walk over there real quick. Yeah. So these 2 units right here are new tiny exhaust fans. These are actually what negative pressure fans look like. That's creating that negative pressure down where the containment is. But for this case, these are going to be permanent that we just installed. There's existing loopers. This used to be a mechanical room on this floor. So there was air handlers sitting right where we were that, you know, sucked air in and also exhausted air out. We blanked off the louvers over there, and then we attached new ductwork to have these exhaust out. And that's really, they're going to stay on full time once we're done, just to kind of keep the space a little bit ventilated. That's really all that is. Good question. Who asked that? Yeah. The only other thing that we need to add too, besides the fans, we're putting in new lights just for access and egress. And then over there, it's not installed yet on level 3, but maybe if you saw taking it from an occupied building to an unoccupied building. So like the stringent, you know, building code doesn't necessarily apply to non-occupied vacant buildings. So it's definitely in our favor. You know, when we first started the project, the fireproofing was going to be renamed. We got a change order to abate all the fireproofing off the steel beams because that has asbestos in it. The elevator shafts, you see we just have guardrails around the elevator shaft. There was a time where we were going to keep the plastic in place. that since has gone away in talks with the hospital and also the fire marshal that oversees this project, HCI, and now they're actually going to just allow us to leave the safety rails in place, not build any fire-rated walls, and
everybody. Any questions before we head out of here? Subs? You guys want a sub list? Well, we didn't really get one from McCarthy. Who are some abatement subs?
I did say Chef Steel was their seal right here. They had Transbay was their fire sprinkler sub. Rosalind is their electrician. I'm not sure who the plumber is. Here we have Eagle Bay as our main demo and abatement subcontractor. So that's a huge one. They're running about 40 guys average. Our electrician is Berg. Our plumber is M3, and same with our mechanical guy is also M3.
Who'd you say was for? What's that? Plumbing and mechanical.
Plumbing and mechanical is M3.
M3. Yeah. M3 plumbing and mechanical.
And Roblin, who's also a general contractor, but we hired their framing division to do framing and drywall, and actually
Roblin framing and drywall.
We did do a lot of remodels in the East Wing. We did a couple bathrooms, did some ADA ramp upgrades, and some other patient space.
What company was that?
What's that?
What company was that?
Roblin? Yeah, so they're managing all the finished trades. They have secondary subcontractors under them to do like paint, wall paneling, and some metals.
Did you say what was your general contractor?
That's what I know. We're the general contractor.
Clark general contractor.
Also known as CMI Risk. We're actually the design builder on this project. Design build, so we're the
Clark is design and build.
Right? I know. I kind of scratched my head too. I call it design demo.
Yeah.
We are doing other construction stuff, so it still works the same way where the architect works directly with us. That's the main focus. So like we're the one point of contact with UCDH.
All right, guys. Any other questions? All right, Forrest. Thanks a lot for your time, man.
Absolutely. Yeah. Always a pleasure. I'm sure we'll see you guys around. I'm somewhat involved with the program,
So just a reminder, I don't know if you sent me the email or somebody else, but so Clark is the company right now that's taking applications for the 2-day summit. Is that what it's called?
Yeah. In January. You guys all get that?
Yeah, we shared class. So great company to work for. Big company based out of New England somewhere.
Yeah, it's Mid-Atlantic, Washington D.C. area.
Okay. So yeah, if you guys have any questions, shoot me an email. I can always share Forrest info if you have any other questions. And so next week, we have class at 7 a.m. We don't have a lab scheduled, so unless something changes, I'll send you guys an announcement. But for now, we'll just plan on doing our quiz and lecture at 7 a.m. And then I think the following week, we've got a tour scheduled, so we'll go over that. All right, thanks everybody.
Thank you. Yeah, right on.
Where's parking lot 3?
Parking lot 3, I'm gonna head that way too. So
I went up this
you guys can follow me.
That is my physics.
I'm gonna walk down the parking structure.